Next, we have Gypsum, my clone of Emacs and Lisp written in Scheme, by Ramin Honari. He will answer questions via web conference. You can join using the URL from the talk page or ask questions through Etherpad or IRC.
Hi, my name is Ramin Honari, and I'm here to talk to you today about my clone of Emacs and Emacs Lisp that I've written in Scheme so far. So, I am an Emacs enthusiast since 2017, currently employed as a full-stack developer, mostly working with Python and JavaScript, although my true love is functional programming, especially Haskell and Scheme. I started learning Scheme about 2 years ago, and for the past year I've been working on a project that I'm tentatively calling Gypsum. Naming things is hard. It's not a great name. I'm open to suggestions. But yes, this is the project in which I am trying to write Emacs Lisp interpreter in Scheme. There are many clones already of Emacs. You've probably heard of Edwin, Jed, JEdit, Jove, Lem, MG, Yi, Xyle. Edwin itself is also written in Scheme, MIT Scheme. These only clone the key bindings of Emacs and not Emacs Lisp itself. The only alternative to GNU Emacs that I'm aware of is X-Emacs, which is a fork of GNU Emacs. Most people don't use Emacs for the key bindings. I mean, this is anecdotally speaking, but the people who I've talked to, I would say don't use Emacs for the key bindings. They use it really more because of the power of Emacs Lisp. Emacs is as powerful as any system shell, perhaps even more powerful system shells like Bash. And the reason why it's so powerful is because there's a good programming language which you can use to control everything on your system. You can control processes, you can load and save files, you can create files, you can configure things, you can capture the output of processes in buffers, you can filter text through buffers, and a good programming language is what you need in order to do all of this. So one big goal of this project is to try to stick as closely as possible to the R7RS standard Scheme definition. That is the latest Scheme standard, R7. And this is just because I want my project to work on many Scheme implementations, not just Guile. Although Guile certainly is the reference implementation. So another goal is to be able to run any init.el. So you can take your existing init.el and run it in my program without significant changes. That's one of my goals in the end. I should be able to do that. A lot of people invest significant time in their configs, and it's kind of disruptive if you want to change editors to not be able to use your Emacs Lisp config. And so I think a useful Emacs clone would be able to clone Emacs Lisp well enough that you can run your init.el. And so overall, why am I doing this? That's just because I like the Scheme programming language. I love its simplicity and its power. It's an extremely well thought out language, and it's one of those languages where you can understand the entire language from top to bottom. You can read the entire specification and understand it yourself. It's like the computers I grew up with when I was a kid. They were all very simple computers, like in the late 80s, early 90s, and back then, theoretically, an engineer could understand the entire system at the software level all the way down to the circuit level. You can't do that nowadays, and so nowadays my computer is not really a physical computer anymore. It's the Scheme language standard itself. That is the core of computation, of all of computation for me. And I would like to use it as more than just an academic curiosity. It was originally designed for teaching at MIT, but it's found use in industry, and the R7RS standard is still relatively new. It's over 10 years old at this point, but hasn't. I mean, the Scheme ecosystem itself is already fairly small, and there still, I don't think, has been a whole lot of adoption of R7RS quite yet. Kind of a shame. So I'd like a project like this, a very large scale, kind of a killer app like project where you're developing a text editor and perhaps even an integrated development environment in Scheme. I think would be very useful, just even as a study of, what can this language do. And just overall, there seems to be a lot of interest in Guile-based Emacs, and well, maybe a Scheme-based Emacs, but Guile in particular. There has been talk of changing Emacs Lisp, or the core of the Emacs Lisp, over to Guile for about 30 years or so. Talks originally in the early mid-90s, there were discussions between Richard Stallman, Tom Lord, and Aubrey Jaffer. They considered actually replacing Emacs Lisp with Scheme. In 1999, and going for about 10 years, someone named Ken Rayburn actually started a project where he started writing Emacs in Guile. My project is very similar to this. Here's a quote from his webpage, which is still up, even though it hasn't been updated in 15 years. This project that I have started is for converting GNU Emacs to Guile as its programming language. Support for Emacs Lisp will continue to exist, of course, but it may be through translation and/or interpretation. The Lisp engine itself may no longer be the core of the program. And this is my goal as well. In 2010, Andy Wingo and Ludovic Cortez took maintainership of the Guile project. From 2009, so while Andy, 2009 to 2011, the first Emacs Lisp interpreter was already being implemented in Guile. And even to this day, this Emacs Lisp interpreter ships with Guile. And so this was happening while Andy Wingo took control of the project. In 2011, so shortly after Andy Wingo took control of the project, Guile 2.0 was released. And also in 2011, in the summertime, someone named Robin Templeton, I believe it was the Google Summer of Code project, started actually trying to incorporate libguile, that's the Guile interpreter, as a linkable or loadable library, linking it to the Emacs executable, and then providing some built-in functions in Emacs that allows you to call the Emacs, or call the Scheme interpreter, the Guile Scheme interpreter, from Emacs. And so it's not like a wrapper around the REPL like Geyser or Slime. It's actually the whole Emacs, or the whole Scheme interpreter loaded into your Emacs process. And that means your Emacs will have the ability to actually load compiled Scheme programs and actually run them and share memory with Emacs Lisp processes. And well, Robin Templeton will explain all of this. They're presenting today, and I'm very excited to actually see their presentation. They'll explain everything. So, let's see, moving on. 2020, someone named Vasily Schneiderman, I'm not sure how you pronounce that, published an overview called The State of Emacs Lisp on Guile. Let's see if I have that here. Yep, it's this page right here. He goes into detail about who has done what so far and what can you do in Guile with Emacs Lisp so far, and so on. Like, what is the state of the project overall? And so, speak of the devil, Andy Wingo on social media. So, 2020 to present. Guile Emacs is dead. So there's GCC Emacs now. There's Emacs Lisp is now has its own JIT compiler, and it seems like over the past few years, Emacs Lisp has kind of moved off into the direction of becoming its own programming language in its own right. And it is decidedly Common Lisp flavored. It is very similar to Common Lisp, and that seems to be the direction that it's headed now. And I don't know if there's really any interest anymore amongst the Guile or the Emacs maintainers of continuing with a Guile-based Emacs. But as far as I know, there's still a lot of interest in the community amongst Scheme and Lisp and Emacs users who are interested in maybe continuing to try to get Guile to become the core of Emacs, or if not, what Rod and Templeton has been doing, at least trying to get Guile something, a language, a first-class supported language in Emacs. So that's enough talking. Let me just show you what I have so far. The GUI is barely working because I have very little experience with GTK or G-object introspection. It's very difficult to debug, so it's very slow to develop. Any crash at sea level produces no stack traces. So far, most of the crashes that I've experienced are due to simple mistakes, like passing the wrong data type. So far, not a whole lot of need for GDB or rebuilding all of GTK, glib, and so on with the debugging symbols. But yes, still development's been very slow. I'm learning as I go. I've chosen to use Guile GI as the foundation for the GUI. Let me just load it up quick here. Load main Guile scheme. And this will launch the GUI. I also happen to have a REPL that runs in a separate thread and submits any form that you type to be evaluated inside of the running GUI environment. But you can just type stuff. So hello world. And of course there's, as you can see, it's not quite rendering correctly. This messages thing here. That should be over here, obviously. I haven't been able to figure out how to get those little details down. But yeah, you can do Alt:, and you get your eval, and you can just evaluate like what's an Emacs, or what's a scheme-specific thing. Like import surfy1, and let's see, do iota 20, for example. And so that is the procedure that iterates and produces some 20 elements of a list. Or you can do something like, let's see, string append hello with space world. And you get the result and so on. And Scheme allows you to return multiple values, so what I have done here is just every value is captured in a list, and it prints all of the return values in a list. So if a procedure returns no values, you get an empty list. And that's that. It's still quite buggy, so if here's a bug that I can reproduce fairly consistently. I can, if you do, there seems to be a problem with a widget being freed too soon, so it will crash. I'm going to try and solve that, hopefully, before this presentation goes live. Let's see here. The Emacs Lisp parser is based on Guile Emacs Lisp, so the Guile Emacs Lisp interpreter that ships with Guile, that is what I am using. I've actually copied and pasted the source code from the Guile source base into my own project so that I can iterate on it more quickly. And I've already had to make some modifications to the Emacs Lisp interpreter in Guile. So here's the evaluator. I've actually already modified the parser and the lexer a little bit, and it's at least able to parse all of the subr.el program the Emacs Lisp program. It can actually load that but not evaluate it, or parse it but not evaluate it, read, not eval. By the time this goes live, I will have submitted a patch upstream. And that's another goal of this project, incidentally, is that anything that we can contribute to Guile and any built-in functions that we can implement, I would like to, for this project, I would like to try and contribute upstream to Guile. The Emacs Lisp interpreter is not working well, unfortunately. So this is the copy of the code base from this commit in particular. Well, I can't get it working. I can't actually get the non-copy, the actual built-in version of the Emacs Lisp interpreter to work properly quite yet. So let me quick go to, what is this here? Guile eLisp. So suppose you have this eval eLisp procedure here, and it takes an eLisp environment, and then it evaluates an expression in that environment and evaluates to a value. So this is the standard way of doing it in Guile. If you can see here, you've got this expression, compile expression. This is like eval. And so actually trying to load this, so let's do load, gypsum, let's see here, this is, no, I want to import gypsum backend Guile eLisp. And if I actually want to do this, so eLisp eval, first of all, it says it failed because there's an unbound variable eLisp eval. Don't know what it's talking about. There's no such variable in any of my programs. I have no idea what's going on here. You can try to run eval eLisp on some simple form like +1 2, and it gives you this exception. This works. This is the same issue that I have with all of the every version of the Emacs Lisp interpreter in Guile. I can get it to work with this big L mode, so I can actually do +1 and 2 here. I can do print like to here. That all works fine. It gives me, for some reason, a stack trace here. And yeah, so it's a bit, it's not well documented. The code base is fairly old. As I said, it was developed around 2011, and it's fairly opaque, and I have not been able to figure out how to get Emacs Lisp in Guile working smoothly. So I have started writing my own Emacs Lisp interpreter, and gypsum eLisp eval tests.scheme. It's not entirely ready. I can show you some of the tests at least. Here is a simple Emacs Lisp program that you can evaluate. You got prog n, set QA to 3, set QB to 5, set QC to the sum of A and B, return C. And this at least works correctly. As you can see here, the result is 8. But the let star semantics are not completed yet. Lots of work left to do there. Yeah. So, in the time I have left, I guess I can just talk a little bit about what my plans are for the future. So I would like to begin by evaluating, or actually loading the subr.el into my Emacs Lisp interpreter. I actually have tests set up for that as well, so I can actually select any form I want from subr.el, and I can just run this through my interpreter and test to see if everything is working once I get that far. Yeah, let me just say that this is my formal appeal to the community for help on this project. Emacs Lisp has 1,393 built-in functions. I could never implement that many functions on my own. So if this project is going to be useful to anybody in any reasonable amount of time, I'm going to need help. And I know that there are people out there who are very interested in a Guile-based Emacs, and so if you're watching this, please feel free to contact me on social media or over email. My job, the way I see it, is if there's enough interest, and I do get a lot of people interested in starting to contribute, my job will be to document the building and testing process and make sure that it is as easy as possible to contribute code to this project. I want to document the system architecture. I'll write blog posts. I'll do videos on PeerTube explaining how everything works. And I will prioritize which built-in functions I think are probably going to be the most necessary, the most essential to get the interpreter running, and then find low-hanging fruit functions that are easy for people to implement as a good introduction to getting them started on contributing to the project. And then, of course, I will take responsibility myself of making sure that we can get the eLisp interpreter to the point where it can run the Emacs regression tests. And these are the test suites that are used to test Emacs Lisp itself in the GNU Emacs code base. And so ERT is itself written in Emacs Lisp, and so I think if we implement enough of the built-in functions to be able to run ERT, then we can actually start using the GNU Emacs regression tests to test our own interpreter, our own Emacs clone. And of course, I'll make sure that there's at least one usable GUI. I'm currently working on Guile GI and GTK. It would be great to have a curses-based, an ANSI terminal-based, something that works in your terminal emulator. And yeah, it would be great if someday soon, hopefully, we get enough done that you can actually contribute a patch to this project from within the Gypsum editor itself. I was going to do an overview, but that would be for more of an hour-long presentation. So I'm out of time. I guess the last thing I should quickly say is there's no meta object protocol in this project. I think that's a little bit too difficult to port to various scheme implementations. So I've created a substitute, which I'm calling functional lenses, which is inspired by the Haskell project of the same name. Everything in this project is based on functional lenses. Yeah, I also went a lot of work into the Emacs data structure. The point being that I think I have a pretty good foundation here upon which we can build, even though there isn't a lot done in the actual prototype itself, not yet anyway. But I made sure to get the fundamentals down from the beginning, and so I think we have something, a solid foundation on which to build. So I'm going to conclude it there, and here's my contact details. Like I said, this is a project I'm appealing to the community of all people who are interested in Guile and Emacs to help contribute to this project. I see myself as just getting the ball rolling again, taking off from the work that Ken Rayburn left behind with my own, from the ground up implementation, though. So yeah, contact me, email. You can take a look at my blog where I talk about what I have done. My source code, the code for this project, is up on Codeberg. And the presentation, the homepage for this presentation, you can find more details there. And yeah, I'm on ActivityPub as well. So my handle is RaminHal9001 at fe.disroot.org, and I'm on every day. So yeah, please feel free to contact me if you're interested, and thank you for your attention. Hi, I'm ready for questions if anybody wants to join. I'll be here for an hour or so. I want to see the next presentation. Sorry, I have a bit of a cold. The next presentation is on Rust, an implementation of Emacs and Rust. And I've talked with the author of this presentation myself. Let me quick try and find that. So I was going to mention this. This is Troy Hinckley's project that I'm talking about. I was going to mention this in my presentation, but it's possible, theoretically, that Troy Hinckley, his project could be used as a scheme implementation that actually runs my own version of Emacs. And although, this is completely theoretical, and I don't know how difficult that would be, but if Troy Hinckley implemented enough of the R7RS standard in Rust, it would theoretically be possible to run the Gypsum editor in Troy Hinckley's own editor. So I thought that was kind of interesting, and I thought it was worth mentioning, at least in the questions and answers. I also mentioned this in the presentation. I wanted to see Robin Templeton's project presentation, but unfortunately it's going to be at like 4 in the morning for me. So I'm going to try and watch that tomorrow, but that's also going to be a very interesting project to keep an eye on if you're interested in Scheme. That's the project where you've got the Guile interpreter running inside of the Emacs process. It's dynamically linked as a library. I'm ready for questions from anybody. You can ask or you can type. It's up to you. Okay, let me check the Etherpad. Let's see here. I'm not sure if I'm doing that right. Let me check one more time. Oh, there it goes. Let's see. So this is. I didn't know about that first bit of history. Oh, I've heard RMS say that Scheme Guile is just a nicer Lisp, but didn't know there were concrete talks attempts to use Guile for Emacs that early. Let's see. That was from Janicki. I'm curious to know how the hell Guile Emacs deals with all the dynamically scoped modules out there. Is there any effort to automatically modularize and name? Let's see. Guile Emacs. If that's that might be a better question for Robin Templeton. In my own project, um, I have just there's no module system for Emacs Lisp. There's a module system for Scheme, and the Emacs Lisp interpreter runs in its own environment. So the require system or whatever system module system that Emacs has, once it's implemented, all of that would just happen inside of the Emacs Lisp environment, which is inside of the Scheme environment. And environments are objects in Scheme. So I think a more difficult question is how to handle threading, and Scheme has very good threading built in Surfy 18. But I don't think it will be easy to write foreign Emacs Lisp foreign bindings to the Scheme multi-threading implementation. Emacs Lisp is just not cut out for that kind of thing. So I think each Emacs Lisp, you could, I suppose, have multiple threads, each running their own Emacs Lisp environment. Scheme would make that very simple to do. And then there'd just be a question of how you would get those different interpreters to communicate with each other, perhaps using the same protocol that's used by the Emacs server. But I haven't thought that far ahead yet. Would it be possible to support a GUI toolkit other than the GTK, like how Emacs still supports Lucid? Yes, this is absolutely a goal of the project. I'm trying to keep the backend as separate as possible. The Scheme has what you call parameters, and these are like global variables that are still somewhat thread safe. And every call to the GUI goes through a parameter. So the Emacs, the interpreter and the editor logic is all in one module. And then that module calls out into a separate GUI module. And then you can implement different GUI modules. So you could have one for GTK3, one for GTK4. If you want to write the extern-C bindings around Qt or Fulltick, that would certainly be possible as well. It would be nice maybe to have an SDL implementation based maybe on Chickadee or some kind of immediate mode GUI, something like that. But definitely GTK3 through Guile GI is the reference implementation. Things start there. But I'm very interested in supporting other GUIs, yes. Let's see. Question, do you plan to provide improvements to eLisp as a language or focus on a compatibility layer to facilitate all new extensions in Scheme? Yeah, the second one. I want to move off to Scheme. I would like for this project to try and keep up to date with each new release of Emacs and Emacs Lisp. That's a difficult moving target to follow, I realize. But to the greatest extent possible, any new features to Emacs Lisp will be pulled in from GNU Emacs. If we happen to be able to implement something cool in Scheme and be able to port it over to Emacs Lisp, then sure, it'd be nice to be able to upload or to submit that upstream to the GNU Emacs. But I think I would prefer to have new features written in Scheme. I would like this Gypsum to be more of a Scheme app platform that just happens to be able to also run Emacs Lisp. That's how I see it. Of course, this will be a community project, so I'm open to debate about that if anybody wants to convince me otherwise. Why is being able to interpret all of .el useful goal? Sure, there's a lot of code written in eLisp. Can we consider... Oh, it's still being written. Please go ahead and finish writing. Can we consider a translator like utility to convert eLisp to Scheme once Guile Emacs has become a reality? Certainly. For the time being, I just wanted to get the interpreter running. So the Guile Emacs Lisp, the one that was written in 2011 that I didn't write, that actually does compile to I think it's the tree intermediate representation. It's one of the intermediate languages that Guile uses to compile Guile Scheme itself. So the Emacs Lisp that was written before actually does that. It actually compiles and makes use of the entire Guile compiler toolchain and actually produces like JIT compilable binaries, which is really cool. like I said, that's the one that I had trouble getting to work properly. And so maybe we can follow that architecture. I'm not sure how to do that, but I would like to be able to do some kind of translating, um, keeping in mind that we want to have this be portable to various schemes. And so Guile makes this very easy, but other schemes don't. Gambit might do this pretty well as well. It compiles to C and then compiles C down to a dynamically linkable library. So yeah, I think probably the most portable, I'm just thinking out loud right now, most portable implementation will just be able to translate Emacs Lisp directly to Scheme, which is not what the old Guile Emacs Lisp implementation does. That goes to TreeIL, so it's very, very Guile specific, can't be ported. But yeah, if we could somehow get Emacs Lisp translated to Scheme and then compiled, say in Scheme or Gambit or MIT Scheme or one of those other compilers, that would be very cool. And I would absolutely love to do that. And I would very quickly accept any code into the code base that would do that. Oh, and to answer the question about init.el, it's just because people spend a lot of time on their configs, and it would be nice if you're starting to use this new editor and want it to be as similar to Emacs users, just the Emacs community in general, and people who are familiar with using Emacs. It would be more useful to everybody in the Emacs community if this were more compatible with GNU Emacs. And so that's why I think that's an important goal. Question is not yet. Great. Oh, here comes another question. Okay, what is the plan to handle ELISP packages that depend on third-party or external libraries like libgit or magit or ripgrep? So that's going to be tricky. It depends on how these external packages are linked into Emacs. If it's going to be a dynamic library like Robin Templeton's project, which you load the libguile library into the Emacs process, that is going to be extremely difficult. So if you have like an external library like I don't know, libgit or what's the GUI thing? Cabal. No, not Cabal. Cairo. Lib Cairo to do SVG graphics and so on. You can do that very easily with Guile, but then on top of that, implementing Emacs Lisp bindings to it.
Next, we have an experimental Emacs core in Rust by Troy Hinckley. You can ask questions in the web conference by joining from the talk page, or you can ask questions through Etherpad or IRC.
Hello, EmacsConf. My name is Troy Hinckley, and this is my talk on Rune, a Rust implementation in Emacs. We strive to be bug compatible with Emacs, so you can use the same eLisp. It's still a very early stage experimental project, and we have some basic things implemented. So before I get started, I want to talk a bit more about what the core is. So the Emacs core, it includes the runtime, the interpreter, garbage collector, everything used to run the code. It includes the GUI. It includes all the data structures. If you look underneath all the ELISP data structures, there's C code underneath there, as well as the auxiliary functions, of which there's about 1,500. And in making this talk, I don't want to give the impression that I'm saying the core is outdated or that it needs to be replaced or that it can't be evolved on its own, because clearly it has continued to evolve. If we look in just the last few years, we can see that we've added native compilation, we've added tree sitter support, we've added color emoji, and there's work right now to add a new garbage collector to Emacs as well. So why create this project? Emacs has a long history, it has a lot of users, it needs to support a big community. And so because of that, it has to be very conservative about what things it can allow into the project. And forks like this create an opportunity to experiment and try new approaches. And this is particularly a good use case for Rust because the C core, it's pretty well tested. It's been around for a long time, a lot of the bugs have been ironed out. But when you're doing a new greenfield project, it's very easy to introduce new undefined behavior and memory unsafety and stuff like that. And Rust protects us from most of that, but it also gives us the ability to be fast and has a strong ecosystem behind it. Rust is also really good at multi-threading. Their phrase in the community is fearless concurrency. They should be able to write concurrent programs without having to worry about data races. It's also really high performance. It has a really good regex engine. It's known for its non-copy I/O as well. So how does this compare to other Rust and Emacs projects, of which there's been a couple? The first is Remax. So this project was the first. It took an outside-in approach. So basically, you could take a C function and replace it with a Rust function and build it together as one executable. And this is pretty easy to do because they could both talk over the C ABI, and you could swap out functions once at a time. So they made really good progress at first. But eventually they ran into the problem that as you get down to the really core parts of it, you can't just replace one function at a time anymore because some of that functionality is connected to other things. Like for example, you can't replace the garbage collector without replacing the entire garbage collection system. And so the progress really kind of slowed down. Another issue with it is that they were doing a one-to-one rewrite. So they weren't adding any new features or functionality, just taking the same code and replacing it in Rust, which doesn't add any advantages in and of itself. So this spawned Emacs NG, which was kind of the spiritual successor to Remax, where they decided to add new functionality, the biggest one being a JavaScript runtime, as well as some new renderers to Emacs. This is no longer actively developed though. So in this project, one of the big focuses we have is on multi-threading. The C core itself everything is designed around being single-threaded, all the data structures and everything like that. And Rust has a great concurrency story. In Rust, everything is intended to be multi-threaded. That doesn't mean that everything has to run on multiple threads, but you can't write something that is limited to only running in a single-threaded environment. And so this makes it really easy to use all the existing packages and build something that is concurrency safe, which is what we've done here. And that was relatively easy to do. But adding it to eLisp is the hard part because we got to come up with a good model for the Lisp, and eLisp is just a giant ball of mutable state. So we need to find some way to tame that so we can make workable concurrency out of it. And there's really two ways you can do this. One is what I call the no-gile method. This is what Python is doing, where you take all of your data structures, you make them concurrency safe, and then you just leave it up to the programmer to decide what they're going to do with it. They've got to build safe abstractions on top of that. One of the big downsides with this is that it comes with a pretty high cost. The last benchmarks I've seen is that by making everything concurrency safe in Python, single-threaded code is about 20% slower in some benchmarks. And so since most code is single-threaded, this has a big performance impact for most code that isn't taking advantage of the multi-threading. The other thing is this introduces a lot of nasty concurrency bugs because you can have anything mutating any part of the data from any thread, even if you can't have memory unsafety per se. The other option is actors, which are a really known way to approach this, where you trade some of that flexibility that you get with fully concurrent for more control. And code and functions are shared between all the different threads, but data has to be passed along channels between different actors. So we want the functions to be shared, and this should be pretty easy because we don't mutate functions like we do data, except when we do. So in Lisp, functions are just lists like anything else, and so you can mutate them just like lists. And even if you're not talking about interpreted code, like even if you have a native compiled function, you can still mutate the constants inside the function. For example, here we have a function returns a string. We take that string out, we mutate that string, and now the function returns a different string. So in Rune, we enforce that all functions and their constants are immutable. You can't mutate the insides of a function. You can still swap out functions and redefine them, but you can't mutate the inside of a function. So this enables them to be safely shared across threads. However, there are some caveats to this. For example, some functions actually do need to mutate their own data. The example that we run into is CL generic. It uses a method cache, and so it has to be able to update that cache. And in this case, we just made a special case for this particular situation, but we don't know what more of these we're going to run into in the future where this is needed behavior to be able to mutate a function. Okay, so functions are pretty easy. They just can be shared between threads, but data can't be immutable. At least not inside the model that Emacs currently has. So we have two different ways to handle this. One is we require, whenever you're calling some other code in a different thread, you have to send all the variables that it's going to need over to that thread. And this is how you traditionally do it inside actors. Any data that needs to go to a different actor needs to be sent over a channel. It's relatively easy implementation. But this is difficult in the Emacs case because everything is going to be accessing different variables. And that means when you call something, you have to know ahead of time all the different variables that are going to be accessed inside that other thread and put those in when you call it. So the other option we're using is we're copying values to the other threads on demand. So if you're running a thread, it tries to look up a variable, it doesn't have any value for that variable, it will go back and ask the main thread, and it will copy that value into that thread, and you can continue execution. This is nice because you can just launch some code and it'll take care of handling all the data transfer for you. What we don't want to be copying around is buffers because they can be really large. So in this case, we have a mutex. Each thread can only have one current buffer that it has an exclusive lock to. This comes with some trade-offs. Big one being that if the user tries to access some buffer, they want to type something, and a background thread is holding onto that buffer, what do we do in that situation? And we still need to hold an exclusive lock, even if we're only going to read a buffer. If you have multiple readers, they each still need to take turns because we can't determine if at some point a thread is going to try and mutate the buffer. So it has to be an exclusive lock. The other issue is buffer locals. And this is less of a implementation issue as much as it is a technical issue. Because you think about when we switch to a buffer, it has some buffer local data and we have some thread local data. And as we go through, we're mutating everything, those can get intertwined and pointing to each other. And then when we switch away from that buffer, we need some quick way to be able to separate those out. So the buffer locals can go with the buffer locals and the thread data can stay with the thread data and make copies of anything that was pointing to the other side. But we don't have a good method to determine how to separate those two, like what data belongs to this and what data belongs to this, so that we can do that quickly. And we haven't found a good solution to that yet, but it's something we're still working on. So the question is, would this actually be useful for doing real work inside Emacs? And I would say, yes, there's a lot of things you could do with this. You could handle process output in the background, you can do syntax highlighting, you can do buffer search in parallel, you can do LSP, you can do fetching your mail in the background, you can have a window manager that doesn't block your window manager when Emacs is blocked. And as well as you could do something like a file system watcher that keeps up on files without blocking Emacs. This wouldn't be so great for building concurrent data structures or operating on shared data or building your own abstractions because the trade-offs that we've made here. Okay, so that's talking about multi-threading. The other thing we're going to talk about is precise garbage collection. In Rune, we have a safe, precise garbage collection because of the REST type system. So let's look at what the problem is with garbage collection in the first place. And really the tricky part about garbage collection is rooting. How do we find out what the roots are? And these are all the values that are on the stack or into the registers. So in this example here, we allocate an object, we call garbage collect, that object's collected, and then we try and return it, it's no longer valid. So let's look at how Emacs used to deal with this problem way back in the day. There was a system called GC Pro or GC Protect, which is basically designed that every time a value needed to survive past a garbage collection point, you had to try and protect it. And in order to do this, you had to declare a struct, you had to put a macro around it to root the object, and then you had to unroot it when you were done past the garbage collection. And now the value is safe. You can see down here, I pulled these 8 rules out from a really old version of the Emacs manual about all the things you had to keep track of when you were trying to use this system. All right, so there was a special handling for nested GC protects. You had to make sure the memory was initialized. You had to make sure that traps couldn't occur between allocating and when GC protect would happen. And it can be tricky because you don't always know when a function that's getting called could potentially call garbage collection. And so if you got something wrong, you also might not catch it for a long time because garbage collection may only get called 1 out of 99 times. The other 99 times is just fine. And that one time, it happens and you can't reproduce the issue. And when you do get this wrong and something doesn't get rooted and it gets overwritten, it generally doesn't show up right where the problem is. It gets showed up way later when you actually try and access the value and the value is invalid. And you got to track it back to where that thing did not get properly rooted. So it's a huge source of bugs. and very hard to maintain. So the Emacs decided to go with a different path, which we call conservative stack scanning. So basically the garbage collector just looks at the stack and all the registers, and any data inside there that looks like it could be a pointer, it treats it as a pointer. This is nice because you get really easy root tracking, but it also comes with some trade-offs, mostly that your objects are no longer movable. So why would we want movable objects in Emacs? There's a couple different reasons. One is compaction. You can take all your heap, you can pack that on down because you can coalesce all your objects together. Another is that it's easy to implement generational garbage collection. You can just copy everything out of your minor heap into your older heap. And really, Emacs is kind of uniquely ideal for generational collection because the typical way we interact with Emacs is as a series of commands. You execute some command, you execute the next command, you execute command. It could be happening every key press. It could be happening with MX. And however long that command is, that is the ideal length for the minor collection generation, the first generation. Because once you're done with that generation, anything that's still existing is going to be around for a very long time. And so that works out really well for Emacs. So we want to make this a generational collector. The other thing is with object layout. We use a lot of lists inside Emacs Lisp. And every time you go to the CDR, you've got to be chasing a pointer around the heap and following that. And that can potentially result in cache misses and all sorts of other things like that. And so it can take a long time. It can be quite slow. But if you have the ability to move objects, you can just relocate an entire list and lay it out in an array right next to each other inside memory. And so iterating over it is just as fast as iterating over an array. But you can only do that if you have movable objects. And I'll point out here too that with conservative stack scanning, it's not that all objects are immovable. It's only ones that are pointed to from the stack or from the registers that have to become immovable. So let's look at how Rust makes precise garbage collection easy. So here I have some Rust code to show kind of how the lifetime system works and what we call XOR mutability, where we can only have one mutable reference or multiple immutable references to the same thing. So here we declare a vector, we take a reference to the first element of the vector, and then we mutate the vector. Now this could potentially resize the vector and move it to a different location in memory. And so that reference is no longer valid. And the nice thing is, Rust catches this for us. It says, hey, this is no longer valid. This reference can't survive past when you mutated it. Okay, that's exactly what we want for a garbage collector. You can see here, we take this in a garbage collection context. We create a new context object. We add an object. We call garbage collect. Then we try and access that object. It's no longer accessible. And Rust will prevent us from trying to access that variable. It's gone. And so how do we solve this? We have a root macro. We declare this root macro. It lets us take that object and let it live past garbage collection. And everything works out. And the nice thing is, this root macro will get dropped when it's out of scope, so we don't have to worry about the un-GC protect step of this. So statically, Rust will verify and tell us any object that needs to be rooted. If we try and access it, it'll tell us it's invalid. We add this root macro, and then we can access it. And so in that way, we have safe, precise garbage collection without any chance of introducing undefined behavior, which is really, really powerful. And it's really easy because the type system will catch it all for us. There's some other Rust niceties I want to kind of talk through that are useful but are not, star features. One is proc macros. So you can see up on the top, you can see how you declare a function inside the C core. All right, you have to use the macro, you have to put the list type, the function type, the struct type, the different types of arguments or different number of arguments, the doc string, and then you can put your argument listing down inside there. On the Rust side, we just write this like we would any other Rust function. And then we put the defun proc macro on there and it takes care of everything for us behind the scenes. And a couple cool additional things we can do with this is that we don't have to make everything just an object. We can actually make things more specific types. So here we have symbols. And as well as you can see subfeature, it's an optional parameter and we just make it an option inside Rust. And it automatically make it an optional inside ELISP. This makes them really easy to write. And I can't take credit for this because this is something that I saw inside Remax and I stole from them. But it makes the functions really easy to call from each other and really easy to write as well. Another thing that's really nice is sum types. So in the C core, if I wanted to get a string out of an object, I would first need to check that it's a string and then dereference it as a string. But if it's not a string, I'm going to introduce undefined behavior. And so in complicated code, I have to make sure that I have always checked what type it is before I try and dereference it to that type. We don't have to worry about any of that inside Rust because we can untag a value and we can use their sum types, basically create an enum, and we can match on what the different values can be, and then we only get out the types that are viable or are actually there. And so we never accidentally get something out of an object that we didn't mean to, or dereference it something that doesn't really exist. We can just match on it and we can get out the values that we need, which is really, really powerful. So there's some other Rust niceties as well working with here. One is the regex engine inside Rust is really fast, high performance. And we are using that for the ELISP regex engine to give it high performance and worst case guarantees. The other is that Rust has a lot of really good parsers for things like JSON that are no copy parsers that are high performance, and we can use those inside Rune as well. There's a handful of other changes we're working on that are not Rust specific, but we'd like to see. The first is being GUI first, terminal second. So this means two things. First is that we have all of our key bindings. Right now inside Emacs, Control-I and Tab are bound to the same key binding by default because that's how it works inside the terminal. In the GUI, you shouldn't have that limitation. The second is that the GUI should not block when Lisp is blocked. It should be independent of that. So your GUI can still continue to operate when Lisp is running. The other is the ability to have an off-screen cursor so that you can be typing on something, you can scroll up and down, and the point doesn't have to follow you where you lose your place where you were before. You don't have to intentionally set a mark. You can just scroll and then start typing and it'll go back up to where it was before, like it works in most applications. And this can be optional. The other is image flow. We want it so that you can easily flow images and you can have large images and scroll past them without jumping, and you can flow text around images. How are we testing this project? Because there's a lot of things that you could get wrong here. One thing we're doing is we're using ERT. So Emacs ships with over 7,000 built-in tests, ELISP tests. And we are using this test suite to test our project as well. So we can kind of use this as a dashboard of saying how close are we to getting to parity with GNU Emacs. The other thing that we have is a tool called LPROP, which is an external utility that basically tests for correctness. Because really, the correctness of Rune is whatever Emacs does, because there's no official spec on how things should behave. And so to do this, we can go look at the Rust function signature, and we know what the arguments are, we know how many they are, and we know what types they should be. And given that information, we can generate a whole bunch of random functions feeding those types in, and then we send a copy over to Emacs, we send a copy over to Rune, they each evaluate it, and they return the result. And we make sure the results are the same. And then we do that for thousands of different implementations of the function. And it helps us find corner cases really easy without having to handwrite a whole bunch of different cases to test things and say, where are these two functions different? So the current status, we already have a multi-threaded ELISP interpreter and bytecode engine inside there. There's no actual text editor in there yet, but the primitives are there. Like you can insert text, move point around, delete text, do different things like that. But we don't have a GUI hooked up to different key bindings to actually type on. There's just a REPL to operate in. We have about 250 of the 1,500 built-in functions already implemented inside there. There's a lot of low-hanging fruit inside this area to still be implemented. The next directions we're working on is we're optimizing the GC. We want to make it generational. Like I said, right now it's just a simple semi-space copying GC. We want to add a proper GUI. We need to implement text properties, overlays, process and job control, all that goodness right there. So how can you get involved? This is hosted on GitHub. You can come on over. If you have any ideas about how to implement something or something you'd like to see done, go ahead and just open an issue so we can have a discussion about it. We've had lots of interesting discussions with different people coming in to the GitHub repo. If you're interested in contributing, the easiest way is probably to run LPROP. Pick some function, run LPROP on it. I promise it won't take long to find some issue, some discrepancy between Emacs and Rune, and that lets you dive into the Rust code and figure out, and the C code, and figure out what the difference is between the two. Or come along and help implement your favorite functionality. This has been a really interesting project so far, and we've had a handful of different contributors on it who just kind of want to learn Rust or get more into systems level programming. Thank you. All right, looks like I am live. Okay, so I'm gonna look at some of the questions showing up in the Etherpad we got here. It says, have you considered using a CRDT to share buffers between threads and merge any concurrent edits automatically? So I have looked at that, and the problem with CRDTs is that even though they give you a mathematically correct answer when you're trying to merge two conflicts, it's not always a useful answer. Like, it's not coherent. If you have two things trying to edit the same thing, there's no good way to resolve that. And so they really work well when you have two people working live, both editing the same document, because they can fix any particular issues like that, like you would with Google Docs. But you have different packages that aren't aware of each other, you're going to run into problems. And so this is something, if you read from the Xi editor, which was one of the first ones to use CRDTs, in the retrospective, he talks about how they had this problem where the CRDTs, they give you an answer, but it's not always an answer that's useful. And so I feel like locks, at least, are going to make it's not going to be as efficient if you have a whole bunch of packages, but I don't imagine there's going to be a ton of those. It can actually, I think it'll be more useful in practice. Why host on GitHub? Because that's what I know. If there's a way to host it on somewhere else, I'd be interested in doing that. If you're interested in setting patches without using GitHub, you could always send an email. I'm more than happy to accept email patches. Do you think it's possible to achieve with the current Emacs code? I do. I think you can do that. Like I said, there's a couple things inside there that are intentional breaks with existing Emacs code. And some of those being like functions are immutable, as well as having data shared, switch between different threads, which means there's going to be some copying going on. So there's going to be subtle things that are going to be different, and we've really got to think about those intentionally. But I'm really going for bug compatibility with GNU Emacs, so that you can take an existing ELISP package and just run it, and it just works. Because I think that's one of the big strengths of the Emacs ecosystem is the millions of lines of ELISP that people have written. So I'm not, okay, so it says you're re-implementing eLisp in Rust. Have you considered using a more modern Lisp such as Scheme? So I'm not re-implementing eLisp in Rust. I'm re-implementing the C in Rust. In fact, I would like to make more of the core that's written in C in eLisp instead of C or Rust, because then it's actually introspectable. There's a talk by Tom Tromey that he gave a while ago about Emacs should be Emacs Lisp. And I kind of like that philosophy, that as much of it as should be eLisp as possible. And we should only have C or Rust or some systems level language for really low level stuff. Using a more modern Lisp such as Scheme. I know there's two talks, I think, in this conference about using Scheme inside Emacs. And I looked at this at one point about what if you wrote it inside Common Lisp, because that also has some really low level details. And then you could go from eLisp down to Common Lisp. But the problem is under the hood, you still need a systems language. You still need either C or Rust or something underneath the Common Lisp to implement the primitives. And so it's not going to give you just two languages. You'll have three. You'll have the eLisp, Common Lisp, and C under the hood. And so in this case, we just have the two. We have the eLisp and the Rust. All right, that's all the questions I see there. Let me go look at chat. Okay, so I see into the chat. Specific features from the Rust compiler that are missing that way you would take advantage of. Oh, that is a great question. There's a handful of them. I should have written down a list of these. One of them is Polonius, which is the new borrow checker. Because we're trying to use lifetimes to track our objects, we often run into situations where we've kind of got to hack around things because the limitations with the borrow checker. And so I have a whole bunch of notes inside there about where a better Polonius would help inside there and help ease some of the issues. Another thing is enum variance as types, because right now we have an object which is defined as a big enum that had all the possible objects. But if we want to have a subset of those objects or just pass in one of those objects, we got to define a new struct. And so we have a whole bunch of boilerplate code to define that all out. And if we had variance as types, that would make the code a lot easier. Another one is the allocator API. Right now, we're kind of working around it, but ultimately, we're going to need our own allocator. And the allocator API is still nightly only. So there's a couple more. I'll look at that more, but that's a great question. Let's see. Okay.
I see a question you might not have noticed, just asking about reuse of Remax.
Oh, yes. So I have reused some of Remax code and some taken, like I mentioned, taken some of their ideas, but ultimately we're using a different model because under the hood in Remax, everything is just defined as an opaque external type that's defined inside Emacs. And so it just pulls those in, interacts with those, and passes them back into C. And so we're trying to see what we can do if we say, okay, we're not going to take the same. So they're bound to the implementation details of Emacs. And we don't want to do that. And so we've re-implemented all the core types ourselves. And so that means that we can't just take the Remax code one for one and use it in our project. But we can take a lot of their ideas, and I've spent some time reading through their documentation, different things about how they approached strings and GC and different stuff like that. All right. Looks like all the questions. Okay, so another question, what are your thoughts on the GUI layer? Any plans on how to re-implement it? So this is something I've thought a lot about, but I still don't have a solid plan for. I'm not really a GUI person. I mostly work with low level. And so my two thoughts is you can go the GTK route. There's Rust bindings for that. That's well understood. It's got good support. But there's also some interesting projects to try and do GUI in Rust, native Rust, and have it use Rust idioms and stuff like that. And so those are things like Druid, and there's eGUI and a bunch of those that are that way. And I've never used one of them, but I'd be interested to try that out first and see how well does this work and how well supported is this doing a Rust first GUI. If money could fix the problem, how much would it cost to ship this with feature parity before 2026? Ooh, in a year. That's a good question. Even if we had the money, it would take more than just me, even if I was working on it full time. I don't know. That's a good question. I would think it would take a team of at least a handful of people to get this shipping within 1 year, because there's still a lot of work to do. And even once you have everything implemented, there's a lot of bug finding and smoothing it out so that it runs as well as Emacs, which has been, battle tested for a long time. Okay.
So this might be a good moment for me to break in and just say that we've got about 10 minutes left before we resume new talks on both tracks. Of course, we're happy to keep this this chat open and keep the recording going here, which we'll share after the conference, as long as there's discussion here.
Thank you. GTK project has automatic binding with a framework called GObject introspection, which is what I'm using for Gypsum project. Probably Rust has a GObject implementation, which you can use. Yeah, I know it has some GTK bindings. I'm not sure if it's specifically GObject, but that's a good path, because I feel like the problem with the Rust GUIs is that they're all very new. And so everything works in a demo, but you need something that can work across all different devices and all different platforms and have really good support and good accessibility and stuff like that. All right, ELISP is implemented in C. So if you're not implementing ELISP in Rust, you're keeping the C implementation of ELISP. So let me see if I can do a better job of explaining this. So inside Emacs, you have about 1 million lines of ELISP. And underneath that, you have the C, which is the primitives everything's implemented in. And so we're keeping all of the ELISP, and we're just taking that C layer and replacing it with Rust. And so when you call a built-in function, it's calling into a Rust function instead of a C function under the hood. So all the ELISP stays ELISP, but the C becomes Rust.
So looking at the IRC chat, it feels to me like maybe there's a little bit of confusion around what do we mean when we say rewriting ELISP in Rust, right? I think there are some people that are like, hey, we're reinventing ELISP, and there's other people that are like, no, we're trying to be byte for byte compatible with Rust. So you're some people are like questioning your no answer on that. Aren't you really? Maybe is what I'm reading in there. Do you want to respond to that?
Yeah. I'm trying to think about how I can make this clearer. So the ELISP stays ELISP. We're not changing the ELISP at all, or at least very minimally. We want to be able to take, like I said, bug compatible. So whatever works inside existing Emacs, you can take all the Lisp and you can run it in Rune and it works the same. So the ELISP stays the same. It's just the under the hood core that is getting replaced. And this in turn adds some new features such as multi-threading. So it's not exactly compatible, but you should be able to use your existing code and the ELISP will stay ELISP.
So the idea is that anything that I've written as an Emacs user, my config, my custom packages, whatever it may be, that's all going to be valid code. If you take, the ELISP implementation as being the C code and the parts of ELISP written in ELISP that represent opportunity space, thinking about Rust as an implementation language, okay, fine. You can make a semantic argument. Okay, we're re-implementing, we're creating an alternate implementation of ELISP. But what ELISP isn't the problem space here. That's a fixed, a given, if you will. Is that all right?
That's a good way of saying it.
Okay. Yeah, what you said makes sense. I was kind of responding to some comments. Like, I'm not sure it connected for everybody. Makes a lot of sense.
Yeah, I wasn't sure how much I needed to expand on that and explain that, but I appreciate you jumping in. Okay, sorry if I already discussed, but will your Rust implementation also be able to run Emacs bytecode, or the implemented the listable? So I already have a bytecode interpreter inside there that runs the existing ELISP bytecode. And so that was one of the first things I did, was bootstrap the interpreter and then bootstrap the bytecode engine. And so we compile, because the bytecode compiler is written in Emacs Lisp. And so you bootstrap that and it gives you the Emacs bytecode. And so I have a bytecode engine that runs the bytecode. So that's already done. And you can potentially on top of that do something like the native compilation or a JIT. But we have both an interpreter and a bytecode compiler.
And I'll just break in one more time to say, with about 5 minutes left in our live time with this Q&A session, which we're happy to keep going. As long as there are questions, coming up in 5 minutes, we'll have a talk on color on the Gen track. And then right here, we'll have the P-Search talk.
Thank you. Is it possible to bootstrap with just the bytecode interpreter? So I'll have to put in a link to one of my blog posts. So that was my original idea, was to say, I don't want to have an interpreter, a bytecode interpreter, and a native compiler. I want to just have just one. So I'm only going to have the bytecode. And so that's what I did initially. The problem with that is that a bunch of the early bootstrap Emacs code is written with the assumption that it's going to be interpreted. This is especially true with macros, where you'll have a function defined, you'll evaluate part of the function. The other half of the function has macros in it that are not defined yet, but it doesn't matter because they don't get used. But with the bytecode interpreter, it expands all macros when it gets the function definition. And so those weren't macros when the function was expanded, and therefore they got instantiated as functions, but they're not functions, they're macros. And so I initially spent a bunch of time trying to work around this, trying to move code around, work stuff around, refactor the code to try and get it to work with only bytecode interpreter. And eventually I just gave up and said, you know what, I'm just going to write an actual interpreter to handle this, because trying to handle all these lazy macros is too much work. And everything in the Bootstrap is built with the assumption that you have lazy macro expansion. Because I'm guessing the Emacs bytecode interpreter isn't complete. So it's mostly complete. There's a handful of opcodes that aren't implemented that are pretty easy to add that I haven't run into. And there's some of them that are deprecated that are implemented, but it's essentially complete. We also provided bytecode JIT compilation via libgcc, the way Emacs currently does it. I did. Eventually, I would like to. I'm more inclined to have a proper runtime JIT than an ahead of time compiler like libgcc, like the current Emacs native compilation, because it allows you to take type information and actually apply that to the code, which can let you do more aggressive optimizations to it. That we may either get a new Emacs with an ancient C core with a modern Lisp, or an Emacs with modern core but stuck with ancient eLisp. So there was another project I was talking to, one of the Guile implementations, about how we could potentially, he was like, what would it take to bootstrap Guile in Rune? Where you have both, you could have eLisp and Guile running inside this project. And so we've started that discussion, which I think would be interesting. But it's tricky too, because fundamentally, eLisp and Guile are two different languages. They have different semantics. They have different ways of handling things. So you've really got to consider both of those when you're trying to make them work together. How would you do the native module system? What would be different? We can do the same thing. We have an FFI. So I haven't looked into it a ton, but I feel like it could be similar. And I'm actually interested. There's a couple projects on GitHub right now to have.
Next, we have pSearch, a local search engine in Emacs by Zach Romero. You can ask questions in the web conference by joining from the talk page, or you can ask questions through Etherpad or IRC.
Hello, my name is Zachary Romero, and today I'll be going over pSearch, a local search engine in Emacs. So search these days is everywhere in software, from text editors to IDEs to most online websites. And these tools tend to fall into one of two categories. One are tools that run locally and work by matching string to text. And the most common example of this is grep. In Emacs, there are a lot of extensions which provide functionality on top of these tools, such as projectile grep, dead grep, consult rip grep, and most editors have some sort of search current project feature. And most of the time, some of these tools have features like regular expressions, or you can specify a file extension or a directory you want to search in, but features are pretty limited. And the other kind of search we use are usually hosted online, and they usually search a vast corpus of data. And these are usually proprietary online services such as Google, GitHub, SourceGraph for code. And let's see. So the kind of search features that editors usually have a lot of downsides to them. For one, a lot of times you don't know the exact search string you're searching for. So some complicated term like this high volume demand partner, do you know if are some words abbreviated? Is it capitalized? Is it in kebab case, camel case, snake case? And you often have to search all these variations. Another downside is that the search results returned are contain a lot of noise. So, for example, you may get a lot of test files. If the tool hits your vendor directory, it may get a bunch of results from libraries you're using, which most are not helpful. Another downside is that the order given is, well, there's no meaning to the order. It's usually just the search order that the tool happens to look in first. Another thing is, so when you're searching, you oftentimes have to keep the state of the searches in your head. So, for example, you try one search, you see the results, find the results you think are relevant, keep them in your head, run search number 2, look through the results, kind of combine these different search results in your head until you get an idea of which ones might be relevant. Another thing is that the search primitives are fairly limited. So yeah, you can search regular expression, but you can't really define complex things like I want to search files in this directory and this directory and this directory, except these subdirectories and except test files, and I only want files with this file extension. Criteria like that are really hard to. I'm sure they're possible in tools like grep, but they're pretty hard to construct. And lastly, there's no notion of any relevance. So all the results you get back, I mean, you don't know, is this search more relevant? Is it twice as relevant? Is it 100 times more relevant? These tools usually don't provide such information. So there's a field called information retrieval, and this deals with this exact problem. So you have lots of data you're searching for. How do you construct a search query? How do you get results back fast? How do you rank which ones are most relevant? And how do you evaluate your search system to see if it's getting better or worse? So there's a lot of work, a lot of books written on the topic of information retrieval, and if one wants to improve searching in Emacs, then drawing inspiration from this field is necessary. So the first aspect of information retrieval is the index. So the reverse index is what search engines use to find results really fast. And essentially, it's a map of search term to locations where that term is located. So you'll have all the terms, or maybe even parts of the terms, and then you'll have all the locations where they're located. And so, like, any query could easily look up where things are located, join results together, and that's how they get the results to be really fast. So for this project, I decided to forego creating an index altogether, as an index it's pretty complicated to maintain because it always has to be in sync. So anytime you open a file and save it, it would have to re-index. It would have to make sure that file is re-indexed properly. And then you have the whole issue of like, well, if you're searching in Emacs, like, okay, you have all these projects, this directory, that directory. How do you know which? Do you always have to keep them in sync? And so it's quite a hard task to keep up to handle that. And then on the other end, tools like ripgrep can search very fast, even though they can't search maybe on the order of tens of thousands of repositories. For a local setting, they should be plenty fast enough. I benchmarked it, and it's about, like, ripgrep, for example, it's on the order of gigabytes per second. So definitely it can search a few pretty big size repositories. So next main task, so we decided not to use an index. Next task is how do we rank? How do we rank search results? So there's two main algorithms that are used these days. So the first one is TF-IDF, which stands for term frequency, inverse document frequency. And then there's BM25, which is sort of a modified TF-IDF algorithm. So TF-IDF, without going into too much detail, it essentially multiplies two terms. One is the term frequency, and then you multiply it by the inverse document frequency. So the term frequency is a measure of how often that search term occurs, and the inverse document frequency is a measure of how much information that term provides. So if a term occurs a lot, then it gets a higher score in the term frequency section. But if it's a common word that exists in a lot of documents, then its inverse document frequency goes down. So it kind of scores it less. So you'll find that words like the, in, is, these really common words, since they occur everywhere, their inverse document frequency is essentially 0. So they don't really count towards a score. But when you have like rare words that only occur in a few documents, they're weighted a lot more. And so the more those rare words occur, they boost the score higher. So BM25 is a modification of this. It's essentially TF. It's essentially the previous one, except it dampens out terms that occur more often. So imagine you have a bunch of documents. One has a term 10 times. One has a term, that same term 100 times. Another has 1,000 times. You'll find that you'll see the score dampens off as the number of occurrences increases. So that prevents any one term from overpowering the score. So this is the algorithm I ended up choosing for my implementation. And so with a plan of using a command line tool like ripgrep to get term occurrences, and then using a scoring algorithm like BM25 to rank the terms, we can combine those together and create a simple search engine, a simple search mechanism. So here we're in the directory for the Emacs source code, and let's say we want to search for, say, the display code. So we run the psearch command, starting the search engine, and it opens up, and we notice it has three sections: the candidate generators, the priors, and the search results. So this candidate generators generates the search space we're looking on. So these are all composable, and you can add as many as you want. And so with this, it specifies that here we're searching on the file system, and we're searching in this directory. We're using the ripgrep tool to search with, and we want to make sure that we're searching only on files committed to Git. And here we see the search results. Notice here is their final probability. And so here, notice that they're all the same, and they're the same because we don't have any search criteria specified here. So suppose we want to search for display related code. So we add a query, display. And so then it spins off the processes, gets the search term counts, and calculates the new scores. And notice here that the results that come on top are just at first glance appear to be relevant to display. And so remember, if we compare that to just running a ripgrep raw, notice here we're getting 53,000 results, and it's pretty hard to go through these results and make sense of it. So that's psearch in a nutshell. Next, I wanted to talk about the story of Flight 447. So Flight 447, going from Rio de Janeiro to Paris, crashed somewhere in the Atlantic Ocean on June 1st, 2009, killing everyone on board. 4 search attempts were made to find the wreckage. None of them were successful, except the finding of some debris and a dead body. It was decided that they really wanted to find the wreckage to retrieve data as to why the search occurred. And this occurred 2 years after the initial crash. So with this next search attempt, they wanted to create a probability distribution of where the crash could be. So the only piece of concrete data they had was a GPS signal from the ship at 2:10, containing the GPS location that the plane was at 2.98 degrees north, 30.59 degrees west. And that was the only data they had to go off of. So they drew a circle around that point of 40 nautical miles, with a radius of 40 nautical miles, and they assumed that anything outside the circle would have been impossible for the ship to reach. So this was the starting point for creating the probability distribution of where the wreckage occurred. So anything outside the circle, they assumed it was impossible to reach. The only other pieces of data were the 4 failed search attempts and then some of the debris found. So one thing they did decide was to look at similar crashes where control was lost, to analyze where the crashes landed compared to where the loss of control started. And this probability distribution, the circular normal distribution, was decided upon. So here you can see that the center has a lot higher chance of finding the wreckage. And as you go away from the center, the probability of finding the wreckage decreases a lot. So the next thing they looked at was they noticed they had retrieved some dead bodies from the wreckage, and so they thought that they could calculate the backward drift on that particular day to find where the crash might have occurred. So if they found bodies at a particular location, they can kind of work backwards from that in order to find where the initial crash occurred. So here you can see the probability distribution based off of the backward drift model. So here you see the darker colors have a higher probability of finding the location. And so with all these pieces of data, so with that circular 40 nautical mile uniform distribution, with that circular normal distribution of comparing similar crashes, as well as with the backward drift distribution, they were able to combine all 3 of these pieces in order to come up with a final prior distribution of where the wreckage occurred. And so this is what the final model they came upon. So here you can see it has that 40 nautical mile radius circle. It has that darker center, which indicates a higher probability because of the crash similarity. And then here you also see along this line has a slightly higher probability due to the backward drift distribution. So the next thing is, since they had performed searches, they were able to they decided to incorporate the data from those searches into their new distribution. So here you can see places where they searched initially. And so if you think about it, you can assume that, well, if you search for something, there's a good chance you'll find it, but not necessarily. And so anywhere where they searched, the probability of it finding it there is greatly reduced. It's not 0 because obviously you can look for something and miss it, but it kind of reduces the probability that we would expect to find it in those already searched locations. And so this is the posterior distribution, or distribution after accounting observations made. And here we can see kind of these cutouts of where the previous searches occurred. So this is the final distribution they went off of to perform the subsequent search. In the end, the wreckage was found at a point close to the center here, thus validating this methodology. We can see the power of this Bayesian search methodology in the way that we could take information from all of the sources we had. We could draw analogies to similar situations. We can quantify these, combine them into a model, and then also update our model according to each observation we make. And I think there's a lot of similarities to be drawn with searching on a computer, in the sense that when we search for something, there's oftentimes a story we kind of have as to like what search terms exist, where we expect to find the file. So for example, if you're implementing a new feature, you'll often have some search terms in mind that you think will be relevant. Some search terms you might think they have a possibility of being relevant, but maybe you're not sure. There's some directories where you know that they're not relevant. There's other criteria like, well, you know that maybe somebody in particular worked on this code, and so what if you could incorporate that information? Like, I know this author, he's always working on this feature. So what if I just give the files that this person works on more a higher probability than ones he doesn't work on? Or maybe you think that this is a file that's committed to often. You think that maybe the amount of times of commits it receives kind of should change your probability of this file being relevant. And so that's where psearch comes in. So its aim is to be a framework in order to incorporate all these sorts of different prior information into your searching process. So you're able to say things like, I want files authored by this user to be given higher probability. I want this author to be given a lower priority. I know this author never works on this code, so if he has a commit, then lower its probability. Or you can specify specific paths, or you can specify multiple search terms, weighing different ones according to how you think those terms should be relevant. So with psearch, we're able to incorporate information from multiple sources. So here, for example, we have a prior of type git author, and we're looking for all of the files that are committed to by Lars. And so the more commits he has, the higher probability is given to that file. So suppose there's a feature I know he worked on, but I don't know the file or necessarily even key terms of it. Well, with this, I can incorporate that information. And so let's search again. Let's add display, and let's see what responses we get back here. And we can add as many of these criteria as we want. We can even specify that the title of the file name should be a certain type. So let's say we're only concerned about C files. So we add the file name should contain .c in it. So with this, now we notice that all of the C files containing display authored by Lars should be given higher probability. And we can continue to add these priors as we feel fit. So the workflow that I found helps when searching is that you'll add criteria, you'll see some good results come up and some bad results come up. And so you'll often find a pattern in those bad results, like, oh, I don't want test files, or this directory isn't relevant, or something like that. And then you can update your prior distribution, adding its criteria, and then rerun it, and then it will get different probabilities for the files. And so in the end, you'll have a list of results that's tailor-made to the thing you're searching for. And so there's a couple of other features I want to go through. So one thing is that each of these priors, they have you can specify the importance. In other words, how important is this particular piece of information to your search? So here everything is of importance medium, but let's say I really care about something having the word display in it. So I'm going to change its importance to Instead of medium, I'll change its importance to high. And so what that does essentially is things that don't have display in it are given a much bigger penalty, and things with the word display in it are rated much higher. And so with this, we're able to kind of fine tune our the results that we get. Another thing you can do is that you can add the complement or the inverse of certain queries. So let's say you want to search for display, but you don't want it to contain the word frame. So with the complement option on, when we create this search prior, now it's going to be searching for frame, but instead of increasing the search score, it's going to decrease it if it contains the word frame. Yeah, so here things related to frame are kind of deprioritized. And we can also say that we really don't want the search to contain the word frame by increasing its importance. And so with all these composable pieces, we can create kind of a search that's tailor-made to our needs. So that concludes this talk. There's a lot more I could talk about with regards to P-Search, so definitely follow the project if you're interested. Thanks for watching, and I hope you enjoy the rest of the conference.
All right, and thanks so much for your awesome talk.
Can you hear the recording, or do I need to pop in?
Yep, we're just starting the recording here in the chat, and I see some questions already coming in. So thank you so much for your talk, Zach, and I'll step out of your way and let you field some of these questions.
Sounds good. All right, so let's see. Going off of the question list. So the first one is about having reduced version of the functionality integrated into iSearch. So, so yeah, with the way things are set up, like it's extreme, like it is essentially a framework. So, you can create a candidate. So just a review from from the talk. So you have these candidate generators, which generate search candidates. So you can have a file system candidate which generates these file documents which have text content in them. In theory, you could have like a website candidate generator, and it could be like a web crawler. Or I mean, so there's a lot of different options. So one option it's on my mind, and I hope to get to this soon, is create a defun, like a defun candidate generator. So basically, it takes a file, splits it up into like defuns, kind of like just like what iSearch would do, and then use each of those, the body of those, as a content for the search session. So I mean, essentially, you could start up a session, and there's like programmatic ways to start these up too. So you could, if such a candidate generator was created, you could easily, and just like, one command, just like get the defunds, make it a part of this, like create a search session with it, and then just go straight to your query. So definitely that's something just like this is in the works. Um, and I guess another thing is kind of interface. So like, I mean, there's the whole dedicated buffer is helpful for searching, but like with this iSearch case, there's currently not a way to like have like a reduced UI where it's just like, okay, I have I have these function defuns for the current file. I just want them to pop up, pretty like at the bottom so I can quickly go through it. So currently I don't have that, but such a UI is definitely yeah, thinking about how that could be done. All right, so yeah, so next question, Andy, how this would work with personal information like Zettelkasten. So this is like, I mean, it's essentially usable as is with Zettelkasten method. So I mean, basically what, like, for example, org-roam, and I think other ones like Denote, they put all these files in a directory. And so with the already existing file system candidate generator, all you'd have to do is set that to be the directory of your Zettelkasten system, and then it would just pick up all the files in there and then add those as search candidates, so you could easily just search whatever system you have. And based off of the ways it's set up, if you had maybe your dailies you didn't want to search, it's it's just as easy to add a criteria saying, I don't want dailies to be searched. Just eliminate the day, like the things from the daily from the subdirectory, and then there you go. You have your Zettelkasten search engine, and you could just copy the. There's. I mean, there, I need. I'm working on documentation for this to kind of set this up easily, but you could just create your simple command, just like your simple command, just like take in a text query, run it through the system, and then just get your search results right there. So yeah, definitely that is a use case that's on top of my mind. So next one, how good does a search work for synonyms, especially if you use different languages? Okay, this is a good question because with the way that BM25 works, it's essentially just like trying to find where terms occur and just counts them up. So I mean, this is something I couldn't get into. There's just too much on the topic of information retrieval to go into this, but there's a whole kind of field of just like, how do you, given a search term, how do you know what you should search for? So like popular kind of industrial search engines, like um, they have kind of this feature where you can like define synonyms, define term replacements. So like whenever you see this term, it should be this. And it even gets even further. Like how do you, like, if someone searches for a plural string, I mean, how do you get the singular from that and search for that? So this is a huge topic that currently P-Search doesn't address, but it's on the top of my mind as to how. Like, so that's one part. The next part is like, for different languages, one thing that kind of seems like it's promising is vector search, which, I mean, with the way P-Search is set up, you could easily just create a vector search prior, plug it into the system, and start using it. The only problem is that kind of the vector search functions, like you have to do like cosine similarity. Like if you have like 10,000 documents, if you're writing eLisp to calculate the cosine similarity between the vectors, that's going to be very slow. And so like now the whole can of worms of like indexing comes up, and like how do you do that, and like is that going to be native eLisp? And so that's a whole nother can of worms. So yeah, vector search seems promising. Um, and then hopefully maybe other traditional kind of like synonyms, stemming, that kind of stuff, like for alternate terms, that could also be incorporated. Okay, next one. When searching by author, I know authors may set up a new machine and not put the exact same information. Is this doing anything to combine these two in one author? Okay, so for this one, it's not. So if like the way the get prior is currently set up is that it just does like a get command to get all the get authors. And you select one and then it just uses that. So, but the thing is if you knew the two emails that user might have used, the two usernames, you could just set up the two priors, one for the old user's email, and then just add another prior for the new user's email, and then that would be a way to just you know get both of those set up. So, and that's kind of a running theme throughout P-Search is that it's made to be very flexible and very kind of like Lego blockish, kind of like you can just, if you need, if something doesn't meet your needs, it's easy to put pieces in, create new components of the search engine. Let's see. A cool, powerful grep rack to maybe have some good ideas, increasing value of searches. Record code while searching. Okay, so okay, that's interesting. I'll have to look into that. This tool. I haven't seen that. There are I do kind of keep my eyes out for these kind of things. One thing I have seen that was kind of that I mean looked interesting was kind of like AST, like the tree sitter grep tools. So like you can grep for like a string in the language itself. So that's something I think would be cool to implement. Either because I mean there's tree sitter in Emacs, so it's possible to do it in eLisp. If not, there are those like kind of like tree sitter tools. So that's something that I think would be cool to incorporate. Let's see. Have you thought about integrating results from using cosine similarity with a deep learning based vector embedding? Yeah, exactly. So yeah, this kind of goes back to the topic before. Definitely like the whole semantic search with vector embeddings. That's something that I mean it would be actually kind of trivial to implement that in psearch, but like I said, computing the cosine similarity in eLisp, it's probably too slow. So and then also there's a whole question of like how do you get the embeddings like like and how do you get the system running locally on your machine if you want to run it that or I mean so that's actually another kind of aspect that I need to yeah look into. Okay, so let's see. Um, okay, next question. Let's see. At the start of the talk, so about just make cover. Is it possible to save bookmark searches or search templates so they can be used again and again? Exactly. So just recently added bookmarking capabilities. So you can essentially just bookmark whatever search session you have. And yeah, and it's just a bookmark you can just open and just like rerun that search from where you left off. So there's that. And then also, I tried to set this up so that there is a one-to-one mapping of a Lisp object to the search session. So from every search session you make, you should be able to get there's a command to do this, um, to get a data representation of the search. So it'd just be like some plist. All you have to do is just take that plist, call this function psearch setup buffer with that data, and then that function should set up the session as you left off. So then like you could make your commands easy. You can make custom search commands super easy. You just get the data representation of that search, find what pieces you want the user to be able to, the search term, make that a parameter in the command, in the interactive code. So you'd have like the parameter at the top, and then there you go. You have a command to do the search just right there. So there's a lot of those things, and there's a lot more that could be done. Like maybe having there's kind of in the works and like thinking about having groups of these things. Like maybe you can set up like, oh, I always add these three criteria together. So maybe I can make a preset out of these and make them easily addable. So yeah, a lot of things like that are I'm thinking about a lot of things about that. So okay, so next question. You mentioned about candidate generators. Could you explain about what the score is assigned to? Is this to a line or whatever the candidate generates? How does it work with our junior demo? Okay, yeah. So so actually I had to I had to rewrite psearch just to get this part right. So the candidate generator generates documents. Documents have properties. So the most notable property is the content property. So essentially what happens is that when you create a file system candidate generator and give it a directory, the code goes into the directory, kind of recursively goes through all the directories and generates a candidate, which is just like a simple Lisp form. It's saying, this is a file, the file path is this. So that's the document ID. So it's just saying this is it's a file and its file path is this. And so from that, you get all of the different properties, the sub properties. So if you're given that, you know how to get the content. If you're given that, you know how to so all these properties come out. And then also the candidate generator is the thing that knows how best to search for the terms. So for example, there's a buffer candidate generator. What that does is it just like puts all your buffers as search candidates. So obviously you can't run ripgrep on buffers. Like you can't do that. Yeah, you can't run ripgrep on just like buffers that don't have files attached. Or for example, maybe there's like an internet search candidate generator, like a web crawler thing. You just imagine it goes to a website, kind of crawls all the links and all that, and then just gets their web pages for the candidates. Obviously, you can't use ripgrep for that either. So every candidate generator knows how best to search for the terms of what candidate it's generating. So the file system candidate generator will say, okay, I have a base directory. So if you ask me, the file system candidate generator, how to get the terms, it knows it's set up to use ripgrep. And so it runs ripgrep, and so then it goes through, it runs the command, gets the counts, and then store those counts. So the lines have nothing. At this point, the lines have nothing. There's no notion of lines at all. It's just document ID with the amount of times it matched. And that's all you need to run this BM25 algorithm. But then when you get the top results, you obviously want to see the lines that matched. And so there's another method to kind of get the exact thing, to kind of match out the particular lines. And so that's a separate mechanism, and that can be done in ELISP, because if you're not displaying, that's kind of a design decision of psearch, is that it only displays like maybe 10 or 20. It doesn't display all the results. So you can have ELISP just go crazy with just like highlighting things, picking the best kind of pieces to show. So yeah, that's how that is set up. Um,
So here's perhaps a good moment for me to just jump in and comment that in a minute or so, we will break away with the live stream to give people an hour of less content to make sure everybody goes and takes their lunch and break a little bit. But if you would like to keep going in here, love to take as many questions. And of course, the we'll include that all when we publish the Q&A.
sounds good. Yeah, definitely. I can go over
And stick around on the stream as we cut away, as we've got a little video surprise we've all prepared to play. Just some comments from an Emacs user dated in 2020 or something like this. I forget the detail. Thank you again so much, Zach, for your fascinating talk.
Thanks. Yeah, so, okay. This makes me really think about the emergent workflows with denote and easy filtering with orderless. Did this or something like this help influence the design of psearch? Yeah, exactly. So, there's just so many different search, like, it's just kind of like, you could search for whatever you want on your computer. Like, there's just so much, like, you can't, yeah, you can't just like hard code any of these things, because it's all malleable. Like maybe somebody wants to search these directories, and so yeah, like um, exactly, like that use case of having a directory of files where um, they contain your personal
I'd like to present to you my newly made Absolute Guide to Emacs video. It's around 1.5 years long. I can send it to you via FTP. So, Emacs, huh? Sure, let me just put on the fireplace. So yeah, Emacs. If you make a change to your text and decide that it was a mistake, Emacs got you covered.
Yeah, all text editors do that.
My friend, let me tell you, but Emacs is not a text editor. Emacs is not that hard. You can learn Emacs in one day, every day. How do I write my blog posts? Emacs. How do I do my project management? Emacs. DNA sequencing? Emacs. Pro monks? Emacs. Taxes? Emacs. Emacs? Emacs.
Really? The RS has an Emacs package?
No. I have to mail the text form. But how do I do my mails? Emacs. The normal way to do it in Emacs? There's no normal way to do it in Emacs. Emacs is fully customizable. Emacs is a fully hackable system. But you know why Emacs is different from other editors, right? Well, Emacs runs in an interpreter. With Jupyter, you're modifying the state of the program. With Emacs, you're modifying the state of the art. The state of the editor. Emacs will never die. Saying Emacs will die is like saying Turing Complete will die. 2 words, org mode. I used to spend hours trying to get the image on the right page. Now I use org mode LaTeX and just accept that it's impossible. I have been using eLisp for 35 years and have recently been diagnosed with parentheses paralysis. I've also been diagnosed with severe hostility towards Vim users. But that's not a real disease, of course. The real disease is Vim. Is Emacs more powerful than Vim? Emacs is more powerful than any OS. I don't have an ego. Killed that buffer a long time ago. Emacs reduces anxiety. Emacs cured my autism. I spend more time customizing my computer than actually using it. It keeps crashing. Emacs is like an instrument. You play it in different major, minor, Dorian modes. Let me show you my major modes. Just what I like to do in my free time, you know. I don't use evil mode. I use crazy mode. I can even use maps in Emacs. Porcelain is the perfect GUI for Git. I check my weather in Emacs. Yesterday my nephew brought me a Nintendo. I said, how can I control this with Emacs? My humor runs in Emacs. I have a very strong pinky finger. I even train my AI in Emacs. Emacs makes you better at terminal at the same time. Although you probably will never have to use the terminal because you can do everything in Emacs. I mean, we could do everything if you want. Emacs is a fully hackable.
How do you copy in Emacs?
Well, now that's a trap question. People ask, what language do bilingual people think in? A lot of people say it's a mix of both languages. But based on sufficient experience, I can tell you that that's not true. I think strictly in eLisp.
Yeah, maybe I will check out eLisp.
What do you mean, maybe? Look, I don't really have the time to play Tetris. Gotta work on that config. Emacs is a part-time job. Yeah, let me teach you. Although you should first read the tutorial. Yeah, I recommend learning vanilla Emacs first for a few years. Default behaviors only undo, no redo. You control undo, the undo, Emacs. So you just press Control X, Control U, K, Meta J, Meta U, 41. But by the way, there's a bug in this, so you need to type create a cursor, create another cursor, create another cursor, select the word, and change it to, I don't know.
Oh, I see. So you're gonna treat this like a text buffer?
I treat my whole life like a text buffer. Yeah, but I don't code in Emacs.
What do you do?
I just read papers. Although mainly I blog about exotic plants. I recently found myself switching between VS Code and Emacs. Pumping so much money into it unfortunately made it better. But I will always use Magit though. Magit. Lex Friedman doesn't use Emacs anymore? Where's my death note? How to make toasters more like Emacs? Now let me go and spend some time bullying non-Emacs users on the internet. I use the U browser, of course. Well, it's got some good knowledge, some good electromechanics. Oh, an image. Vim is for dark people. Emacs is for the enlightened. Yeah, I fought in the Vim Emacs wars. My computer actually boots into Emacs. Actually, it's not just Emacs, it's a few borrowed components from Genera. But it's all Lisp-based, and it's astonishingly slow. Look at how little memory my computer got. Well, look at it. Regardless of how you configure Emacs, Control H is what unites all Emacs users. Space Max? What are you, 5? We use Hyperspace Max. Control X, Control K, Meta H, 42. Yeah, this is a good old plastic. Only in Emacs you can set bookmarks to jump in between text. What did I? Oh no. Hold on. Oh, hold on. Redo. Oh, hold on. So you can just run. Oh, hold on. Let's go. With Emacs, you will never have your heart broken again because the editor you love and its developer just fold up and leave you with a useless piece.
How long would it take you to learn it all?
Okay, so if ELISP is as powerful as the universe, and the universe was created in plus minus billions of years, that would be billions of years. I work only part-time.
Wait, what do you do full-time?
Emacs. Emacs is a part-time job.
Are you ready for lunch?
Yeah, sure. Let me just go into the comment section and tell people they should use Emacs. Nah, I'll bully some Vim users. You know, Emacs has a package for that.
I think Vim has quite a nice tutorial.
I don't remember.
Remember what?
I don't remember asking for your opinion.
Well, there is no best editor. In fact, it's impossible for one to be the best, right?
Yeah, I feel you can leave at this point. You haven't learned anything. Yeah, you can do this in Emacs. I mean, I can't imagine wanting this, but a man's Emacs is his castle. Control X, Control B, you can switch quickly between things.
Yeah, so it's like Control Tab on Mac.
What is Mac? I spend 20 hours on this, but only 5 minutes writing. I hope there's also a package coming up with research papers. By the way, for all of this, we could set key bindings. And you can bind the key binding to shorter key bindings. Where is that in it?
Also, when it crashes, you can recover from the tilde files.
Why would Emacs crash?
ChatGPT might take your job in helping people with Emacs.
No. I'm part of the culture here. Dear diary, today ChatGPT is better at writing ELISP functions than me. But I will always use Magic though.
Notice you only have the second page of the reference card printed.
Yeah, but I know the other page by heart.
But you don't know the second one. Okay, that sounds pretty unintuitive.
It is intuitive. Look, it works for me, okay? No. Yes. No! Let's see what this does. See, can your ID do this? Oh, that deletes the region. It doesn't kill it. This is the key on the keyboard usually labeled backspace. The same one you normally use outside Emacs. I don't use anything outside Emacs.
Well, you say you want to start working on it now.
No, I want to keep modding, so it's fun once I start working. You want my Emacs configuration? Look, this is a life of work. One does not simply share his Emacs configuration. This is all personalized to my quirks and misdemeanors. I spent all my life configuring this. Literally, I didn't do anything else than configuring Emacs. JK.
Aren't those Vim commands? You're in evil mode? Okay, I see why some software engineers might prefer Emacs.
Software engineer? Who's a software engineer? This is the school of law.
You're a law professor.
No, I'm a Zen monk. The only thing that I do in this department is fixing people's Emacs. I mean, I could probably automate this. Well, let me just write it out real quick. I mean, I could probably do this in a smarter way. Yeah, it's kind of pointless.
Pointless?
It's hard, okay? Well, that's the thing you don't understand. People never quit Emacs. They just die at some point. Yeah, Emacs has a package for that.